February 22, 1943. The Tunisian desert lay still under a pale morning sky. Near the town of Sbeitla, the wreckage of American tanks dotted the landscape like scattered monuments to inexperience. Smoke still rose from blackened hulls. The Battle of Sidi Bou Zid had ended badly for the 1st Armoured Division. Preparing and narrating this type of story took us long efforts and hard work. So if you are enjoying the story, please consider subscribing to our channel. Among the debris, one machine sat different from the rest. An M4A1 Sherman, serial number USA 3067641, built just 8 months earlier at Lima Locomotive Works. Its name, War Daddy 2, was still painted proudly on its hull. But this tank hadn't burned. Its crew had abandoned it, intact and operational, leaving behind not just a vehicle, but a window into American industrial capability. German salvage teams approached carefully. By 1943, they'd recovered countless Allied machines, but this was different. This was America's newest medium tank, and it had fallen into their hands almost untouched. Within hours, orders came down from high command. This machine would not be repurposed for frontline combat. It would go home. To Kummersdorf. If you're enjoying this deep dive into the story, hit the subscribe button and let us know in the comments from where in the world you are watching from today. The journey began immediately. German crews, careful not to damage their prize, drove the Sherman 350 kilometers to the port of Sfax. It took 4.5 days, the American tank rumbling along under its own power, its engine proving more reliable than many of the vehicles escorting it. At Sfax, War Daddy 2 was loaded onto a ship bound for Germany, destined for the Wehrmacht's premier testing facility. Kummersdorf sat 25 kilometers south of Berlin, nestled in the Brandenburg countryside. Since 1875, it had served as Germany's primary weapons proving ground. By 1943, it had become something else entirely. A museum of enemy capability, a library of Allied technological secrets, and soon a place where German confidence would face an uncomfortable truth. When War Daddy 2 arrived in early March, German engineers descended upon it with the methodical precision their military was famous for. They measured every plate of armor, noting thickness and angle with chalk marks that would appear in photographs for decades to come. They catalogued every component. They stripped away panels to examine the internal workings. And slowly, a picture emerged that contradicted years of propaganda. The Sherman wasn't supposed to be impressive. German soldiers had been told repeatedly that American tanks were crude machines, mass-produced without care for quality or sophistication. Quantity over quality, brute force over engineering elegance. The Americans, they'd been assured, couldn't build precision equipment. They were good at making trucks and tractors, perhaps, but not fighting vehicles. War Daddy 2 told a different story. The hull construction itself surprised them. The front was a single, massive casting, smoothly curved to deflect incoming rounds. German tanks used welded plates, requiring skilled labor and time-consuming assembly. This casting was uniform, consistent, clearly the product of a manufacturing process that could be repeated endlessly. The welds where the cast front met the welded rear were clean, professional, showing none of the variation that plagued German production as the war ground on and skilled workers became scarce. But it was inside that the real revelations waited. The driver's compartment was spacious, well lit, ergonomically arranged. Controls fell naturally to hand. The transmission, a synchromesh unit, allowed smooth gear changes without the brutal double clutching that German designs required. The engine, a Continental radial, originally designed for aircraft, sat in its compartment with ample room for maintenance. Mechanics could remove and replace major components without disassembling half the tank. The turret told an even more compelling tale. 69 inches in diameter, larger than anything on a German Panzer III or IV. This wasn't just about installing a bigger gun someday. It was about crew comfort, about efficiency, about men being able to work together in a space that didn't crush them against hard metal for hours at a time. The commander had an actual cupola with vision blocks, allowing him to see in all directions while remaining protected. The loader had room to move. Even small details mattered. The seats were padded, adjustable, designed for long missions. Then came the discovery that would change everything. Beneath the gun mount, connected through a system of hydraulic lines and mechanical linkages, sat a device unlike anything in German tanks. A gyroscope, spinning at 12,000 revolutions per minute, powered by the tank's electrical system, the Westinghouse stabilizer. The engineers had heard rumors of this. Intelligence reports from the Eastern Front mentioned that American Lend-Lease tanks sometimes exhibited unusual behavior when moving, their guns remaining oddly level despite rough terrain. But seeing it in person, understanding how it worked, that was something else entirely. The system was elegant in its complexity. The gyroscope, mounted rigidly to the tank's structure, maintained a constant reference to the vertical. As the tank pitched and bounced across uneven ground, the gyroscope detected any deviation from level. Hydraulic actuators, drawing power from the turret traverse system, automatically adjusted the gun's elevation to compensate. The result: a gun that stayed aimed at its target even while the tank was moving. German engineers had experimented with stabilization before the war. Research papers from the 1930s sat in archives, proposing similar systems, but they'd never moved beyond theory. The complexity seemed prohibitive. The weight budget for their tanks couldn't accommodate it. The electrical systems weren't robust enough. Most critically, German doctrine held that tanks should fire from stationary positions anyway, so why waste resources on enabling fire on the move? Now, standing in the workshop at Kummersdorf, examining an American tank that had this technology as standard equipment, those decisions felt different. The stabilizer wasn't there to enable firing while driving at full speed across rough terrain. Tests would later show that accuracy while moving was limited, more useful for keeping the gun generally on target than for precision shooting. But that wasn't the point. The point was what happened when the tank stopped. A Panzer IV crew, engaging a target, had to go through a precise sequence: halt the tank, wait for it to settle as the suspension compressed and rebounded. The gunner, whose sight was rigidly connected to the gun, would find his crosshairs swinging wildly as the tank rocked. He'd have to wait, perhaps 2 or 3 seconds, for everything to stabilize. Only then could he aim properly, make final adjustments, and fire. A Sherman crew did something different. The gunner kept his sight on target as the tank moved. When the commander called to stop, the driver hit the brakes. The tank rocked forward on its suspension, but the gun, held steady by the stabilizer, remained pointed where the gunner had placed it. By the time the tank fully stopped, the gunner was already squeezing the trigger. Perhaps a second had passed, perhaps less. In tank combat, where the first shot often decided who lived and who died, that second mattered more than armor thickness or gun caliber. The German test reports, written in the careful technical language of military engineers, couldn't quite hide their unease. The Sherman's stabilizer, they noted, was something Germany had not managed to install in any production tank. The technology existed in German files, in university laboratories, but not in their fighting vehicles. And here was American putting it in every single Sherman that rolled off the assembly line. At Kummersdorf, more than just testing occurred. In early June 1943, a special demonstration was arranged. Reichsminister Albert Speer, Hitler's Minister of Armaments and War Production, came to see the captured tanks. Photographers documented him climbing into War Daddy 2, settling into the commander's position, examining the controls. The propaganda value was clear, German leadership taking the measure of their enemies. But the propaganda told a different story than reality. The demonstrations at Kummersdorf compared the Sherman directly to German tanks. On flat ground, the Panzer IV held its own. Its later models mounted a 75mm gun with better armor penetration than the Sherman's. In a static gunnery duel, the German tank could win. But war wasn't static gunnery duels. They tested the tanks on slopes. An early Panther prototype, brought to the same demonstration, climbed an incline the Sherman couldn't manage. Good for propaganda, but the engineers noted something else. The Sherman's suspension, with its vertical volute springs, absorbed impacts smoothly. The crew inside barely felt bumps that would rattle a Panther crew's teeth. Comfort translated to endurance. Endurance translated to crews who could fight effectively after hours of driving. They examined reliability. The Sherman's engine, designed for aircraft, was proven technology. Parts were standardized, interchangeable between tanks. The Continental Radial didn't offer the power-to-weight ratio of German engines, but it didn't break down as often either. Field maintenance was simple enough that moderately trained mechanics could handle it. German tanks, with their precisely engineered but temperamental engines, required specialists. Most revealing of all was the production quality. Every weld on War Daddy 2 showed consistency. Every bolt fit properly. Every gauge was calibrated. Every control smooth in operation. This wasn't a hand-built prototype. This was a production tank, one of hundreds rolling off American assembly lines every month, and they were all built to this standard. German tank production in 1943 struggled with quality control. As the war consumed skilled workers, replacements with less training had to fill the gaps. Tolerances varied. Some tanks left the factory needing immediate repairs. Parts from one manufacturer sometimes didn't fit tanks from another, even of the same model. The Germans could build magnificent machines when everything went right, but they couldn't build them consistently. America apparently could. By mid-1943, intelligence reports confirmed what the engineers at Kummersdorf were discovering. North American aviation's factories were producing Shermans at a rate approaching 600 per month, not 600 tanks total. 600 Shermans alone every 30 days. At peak production, one complete tank rolled off the line every 2 hours. The entire German tank industry, all manufacturers combined, barely matched that output, and every single one had a gyro stabilizer. The engineers wrote their reports. Detailed technical analyses went up the chain of command. The conclusions were clear. The Sherman represented a different philosophy of warfare, not better in every measure perhaps, but optimized for a kind of war Germany was already losing. A war of logistics and production, a war where consistency mattered more than peak performance. A war where good enough, repeated 1,000 times, beat perfection achieved once. Albert Speer himself, in private correspondence after the war, would reflect on what he'd seen at Kummersdorf. The American tanks, he admitted, weren't necessarily superior in any single characteristic, but they were superior in being available, reliable, and simple enough that semi-trained crews could use them effectively. The stabilizer epitomized this. Not a war-winning superweapon, but a thoughtful feature that gave American crews a small, consistent advantage. The testing at Kummersdorf continued through the spring and summer of 1943. German crews, experienced Panzer veterans, took War Daddy 2 out to the proving grounds. They drove it across obstacle courses, pushed it through mud and sand, fired its 75mm gun at various ranges. Every test generated more data. Every data point told the same uncomfortable story. The stabilizer worked. Not perfectly. Not with the precision German engineers associated with quality equipment. When fired on the move at 15 miles per hour across moderately rough terrain, the system kept the gun's elevation within 1/8 of a degree, roughly 2 mils. This gave Sherman gunners a 70% hit probability on enemy tanks at ranges between 300 and 1,200 yards, while the tank was still moving. But the real value became apparent in repeated trials of a different scenario. 2 tanks, both moving toward firing positions. Both commanders spot an enemy simultaneously. Both issue orders to halt and engage. The question wasn't which tank had the better gun or thicker armor. The question was, who fired first? German test crews, experienced in their own tank's capabilities, ran the drill dozens of times. In a Panzer IV, from the moment the driver braked to the moment the gun fired, 3 to 4 seconds elapsed. The tank had to settle. The gunner had to reacquire his sight picture. Final adjustments had to be made. Then, and only then, could he fire with any hope of hitting. In the Sherman, the same sequence took 1 to 2 seconds. The stabilizer kept the gun aimed while the tank stopped. The gunner's sight, slaved to the gun, remained on target. By the time the suspension finished compressing, his finger was already on the trigger. This wasn't theoretical. This was measured, documented, undeniable. One German test officer wrote in his report, "The psychological advantage alone is considerable. The American gunner maintains continuous aim from movement to halt. Our gunner must wait, watching his sight picture dance, unable to fire." In combat, these seconds separate survival from destruction. But the stabilizer was only part of the story. The deeper the Germans dug into War Daddy 2's design, the more they discovered about how Americans thought about tanks. Early Shermans stored shells in the sponsons, those bulges on either side of the hull above the tracks, convenient for the loader, but vulnerable. A penetrating hit there would ignite the ammunition, turning the tank into a death trap. The Germans knew this weakness well. Their crews had coined a dark nickname for the Sherman, the Tommy Cooker, or Ronson, after an American cigarette lighter advertised as lighting the first time, every time. Yet by late 1943, American engineers had already addressed this. New production Shermans moved ammunition to the hull floor, below the turret ring, and stored it in water-jacketed racks. If a shell penetrated the armor and struck an ammunition rack, the water jackets would rupture, flooding the area and preventing catastrophic explosion. The fix was simple, effective, and being implemented across the entire production line. This pattern repeated throughout the design. Problem identified, solution engineered, change implemented on all subsequent production. No need for perfect foresight, just rapid iteration and the manufacturing capacity to implement improvements quickly. The Germans, by contrast, had perfected the Panther and Tiger designs through meticulous testing, but changing production midstream was nearly impossible. Their factories, spread across occupied Europe, each had their own methods, their own supply chains, their own slight variations in construction. Standardization existed on paper but broke down in practice. In June 1943, the technical evaluation of War Daddy 2 reached its conclusion. The report, filed away in Wehrmacht archives, stated what German commanders already suspected. The Sherman was, in the words of one engineer, quite a praiseworthy product of the North American steel industry. The turret design was noted as particularly well executed. The stabilizer represented technology Germany had not managed to implement. The manufacturing quality was consistently high. Most damning of all, the Americans were producing these machines in numbers Germany couldn't match, but numbers alone didn't tell the complete story. In the months following War Daddy 2's capture, intelligence officers compiled data on American tank production. What they found revealed a manufacturing capability that bordered on incomprehensible. By 1943, the United States was operating multiple tank production facilities. The Lima Locomotive Works, which had built War Daddy 2, was just one of several plants churning out Shermans. Chrysler's Detroit Arsenal Tank Plant, the Fisher Tank Arsenal in Michigan, the Pressed Steel Car Company in Pennsylvania, Pacific Car and Foundry in Washington State, all building identical tanks from standardized plans. The numbers were staggering. In 1943 alone, American factories produced over 21,000 medium tanks, most of them Shermans. For comparison, Germany's entire tank production that year, including Panzer IIIs, IVs, Panthers and Tigers combined, barely exceeded 5,000 vehicles. But raw numbers understated the real advantage. American tanks were standardized to a degree German engineers found remarkable. A transmission from a Sherman built in Michigan would fit perfectly into a hull from a Sherman built in California. Parts were interchangeable, not just within a factory, but across the entire production system. Field maintenance became dramatically simpler. A damaged tank could be cannibalized to repair others, with no concern about parts matching. German tank production, by contrast, suffered from variation. A Panzer IV from one manufacturer might use slightly different components than a Panzer IV from another. Parts stockpiles had to account for these variations. Field repair depended on which factory had built which tank. The vaunted German precision engineering had become a logistical nightmare. The stabilizer embodied this difference. It wasn't a German engineer's fantasy of perfection, meticulously designed to perform flawlessly under all conditions. It was an American engineer's solution to a practical problem. How do you give tank crews a consistent advantage that can be manufactured at scale? Preparing and narrating this type of story took us long efforts and hard work. So, if you are enjoying the story, please consider subscribing to our channel. Westinghouse, the company that produced the stabilizer, wasn't a specialized military contractor. They made everything from elevators to power generators to household appliances. The stabilizer used mass production techniques developed for civilian products. The gyroscope spinning at 12,000 RPM wasn't some exotic military technology. It was precision manufacturing applied to a military need. This industrialization of war-making represented something Germany couldn't replicate, not because German engineers lacked knowledge or skill, but because the American economy operated at a scale that made mass production of complex systems economically viable. If you find this story engaging, please take a moment to subscribe and enable notifications. It helps us continue producing in-depth content like this. The stabilizer's existence in every Sherman also revealed something about American military doctrine: German tank design. Philosophy held that tanks should find good firing positions, halt, and engage targets from cover. Fire and maneuver, certainly, but firing while moving was wasteful, inaccurate, not doctrinally sound. American doctrine accepted that combat was chaotic. Tanks wouldn't always have time to find perfect firing positions. Engagements would happen suddenly, at unexpected ranges, while both sides were still moving. The stabilizer didn't make the Sherman invincible. It made American crews more likely to survive their first encounter with the enemy, and in tank warfare, surviving the first encounter often meant surviving the war. By late 1943, War Daddy 2 had revealed its secrets. German engineers understood the Sherman's capabilities, its strengths and limitations. They documented everything meticulously. Reports circulated through Wehrmacht headquarters, to tank divisions, to training schools. German tankers learned what they were facing. But understanding a problem wasn't the same as solving it. Germany couldn't build its own stabilizers fast enough to matter. The technology wasn't impossible, but implementing it required electrical components, precision gyroscopes, hydraulic systems, all manufactured to exact specifications. These same resources were desperately needed for radar systems, for aircraft instruments, for U-boat equipment. Priorities had to be set, and tank stabilizers, however useful, couldn't compete. More fundamentally, adding stabilizers to existing German tank designs was nearly impossible. The Panzer IV's turret was already cramped. The electrical system was marginal. The entire design would need reworking, which meant retooling factories, retraining workers, interrupting production. In 1943, with the Eastern Front consuming tanks faster than factories could replace them, stopping production to implement improvements was tantamount to surrender. The late-war Panther, which should have been Germany's answer to Allied medium tanks, actually went backwards in some respects. The final variant, the Panther OSF, F, planned but never fully implemented, would have included improvements. But earlier Panthers, rushed into production to meet desperate demands from the front, lacked even basic features like powered turret traverse. Crews had to hand-crank the turret, like tanks from the early 1930s. Meanwhile, the Americans kept improving the Sherman. The stabilizer that so impressed German engineers at Kummersdorf in 1943 was already being refined. Second-generation Shermans, with larger hatches and improved armor, received an upgraded stabilization system, easier to set up, more reliable. Better training programs taught crews how to use it effectively. The contrast was stark. Germany could build individual tanks that outperformed individual Shermans in direct combat. The Panther's gun could penetrate Sherman armor at ranges where the Sherman couldn't effectively reply. But Germany couldn't build enough Panthers, couldn't keep them running, couldn't get spare parts to the front fast enough. America could do all of those things with the Sherman. The captured American tank at Kummersdorf had demonstrated a truth that German commanders increasingly recognized but couldn't publicly acknowledge. This war wouldn't be won by superior individual weapons. It would be won by superior production, superior logistics, superior ability to keep fighting vehicles in the field and operational. And on those measures, Germany was already losing. In the summer of 1944, more than a year after War Daddy II's capture, German tank crews facing the Allied invasion of France encountered Shermans by the hundreds. They knew what to expect. They'd been briefed. They understood the stabilizer, the manufacturing quality, the sheer numbers they would face. Understanding didn't help. After the war, when historians interviewed German tank veterans, many cited specific moments when they realized victory was impossible. Some pointed to the first time they faced T-34 seconds in Russia. Some mentioned seeing the endless streams of Allied bombers overhead, but many, particularly those who fought in the West, pointed to a simpler observation. They never ran out of tanks. Knock out 5 Shermans in one engagement, and tomorrow there were 10 more. Destroy an entire American tank company, and within days it was rebuilt, re-equipped, back in action. The Americans had unlimited reserves, unlimited spare parts, unlimited ammunition. They could afford to learn through trial and error because they had enough tanks to make errors with. Germany had run out of margin for error in 1942. By 1944, they were fighting with whatever they could scrape together. The gyro stabilizer, in this context, became symbolic, not because it was a superweapon, but because it represented a kind of war Germany couldn't fight. A war where thoughtful engineering improvements, multiplied across thousands of vehicles, created cumulative advantages that individual excellence couldn't overcome. A war where good enough, available now, in quantity, beat perfect, arriving late, in limited numbers. War Daddy II sat at Kummersdorf through 1944, occasionally used for demonstration purposes, gradually becoming less relevant as newer, more advanced Allied vehicles were captured and studied. Its ultimate fate is uncertain. Some records suggest it was destroyed in an air raid in late 1944. Others indicate it might have been pressed into service during the desperate final defense of Berlin in 1945. Either way, by then, its lessons had already been learned. The German engineers who'd studied it understood what they were facing. The question was never whether Germany could match American production. The question was whether they'd recognize soon enough that they couldn't and act accordingly. They didn't. Spring, 1945. The proving grounds, at Kummersdorf, lay silent. Soviet artillery rumbled in the distance, getting closer each day. The meticulous testing that had occupied German engineers for years had ceased. Files were burned, equipment destroyed or evacuated, secrets buried or scattered to prevent them from falling intact into enemy hands. War Daddy II, if it still existed, was just another piece of abandoned metal in a landscape littered with the wreckage of the Third Reich's collapse. But the knowledge that Tank had revealed couldn't be destroyed so easily. The stabilizer story, in the end, wasn't really about a gyroscope. It was about 2 fundamentally different approaches to industrial warfare, playing out across the battlefields of Europe in a contest that had already been decided years before the final shots were fired. Germany had entered World War II with a military tradition built on excellence, precision engineering, superior training, tactical brilliance, individual weapons that, in single combat, could defeat anything the Allies fielded. The Tiger tank could destroy Shermans at ranges where return fire was impossible. The Panther's sloped armor could shrug off hits that would cripple Allied tanks. German optics were superior. German guns were superior. German crews, when properly trained, were superior. None of it mattered. Because America had understood something fundamental about modern war, the nation that could sustain production, maintain supply lines, replace losses, and continuously improve its equipment would win. not through heroism or tactical genius, though those helped, but through the relentless application of industrial capacity. The gyro stabilizer embodied this philosophy perfectly. It wasn't elegant by German standards. It didn't represent the theoretical perfection German engineers prized. What it represented was practical problem-solving at scale. American tankers needed an edge in first-shot engagements. Engineers designed a depincher system that provided it. Manufacturers figured out how to produce it cheaply and consistently. The army integrated it into doctrine and training. Then they built 50,000 tanks with it, not 50 experimental prototypes, not 500 for elite units. 50,000. Every Sherman that rolled off American assembly lines from 1942 through the end of the war carried this technology as standard equipment. Farm boys from Iowa and factory workers from Detroit climbed into tanks equipped with technology Germany couldn't implement in any of its production vehicles. The German response to War Daddy II's capture had been thorough, professional, exactly what one would expect from Wehrmacht engineers. They'd documented everything. They'd understood the implications. They'd written detailed reports explaining how the stabilizer worked, what advantages it conferred, and why Germany couldn't replicate it at scale. Those reports went up the chain of command and disappeared into the bureaucratic machine. German tank production continued along its existing lines because changing course required resources Germany no longer had. The gap between understanding a problem and solving it had become insurmountable. By 1944, the differential was crushing. That year, American factories produced over 17,000 Sherman tanks alone. Germany's total tank production, including everything from obsolete Panzer IVs to sophisticated Panthers and Tigers, reached barely 6,000 vehicles. And those German tanks, however formidable individually, were increasingly crewed by boys with minimal training, supported by a logistics system that could barely deliver fuel and ammunition, maintained by mechanics who lacked spare parts. The Americans, meanwhile, had tanks to burn, literally. They could afford to use Shermans as mine clearers, mounting rotating chains that beat the ground to detonate buried explosives. They could afford to convert Shermans into bulldozers for engineer units. They could afford to lose 3 or 4 Shermans destroying a single Tiger because tomorrow there would be more Shermans and probably no replacement Tiger. German tank crews learned to dread not just Allied tanks but the entire system behind them. An American tank battalion might lose half its vehicles in heavy fighting, only to be pulled back for rest and refit. Within days, brand new Shermans would arrive, still smelling of factory paint. Fresh crews, trained on identical equipment back in the States, would climb aboard. The battalion would return to combat at full strength. A German tank battalion, once depleted, might wait weeks or months for replacements. Those replacements, when they arrived, might be different models requiring different parts, different ammunition, different maintenance procedures. Spare parts came sporadically, if at all. Experienced crews were scattered across whatever vehicles were available, mixed with barely trained replacements. Units fought at 30 or 40% strength and considered themselves lucky. The gyro stabilizer was just one small piece of this larger picture, but it symbolized the entire dynamic. It was the kind of advantage a rich nation could provide its soldiers, not decisive by itself, but added to 100 other small advantages. Tank radios that actually worked reliably, auxiliary generators so crews didn't drain batteries, ergonomic crew stations that reduced fatigue, ammunition storage that didn't turn tanks into death traps. It created a fighting force that could sustain operations indefinitely. German tankers, interviewed after the war, often expressed grudging respect for Allied equipment. Not because it was better in direct comparison, they'd often note that their tanks had superior guns or armor, but because it worked consistently and was always available. One Panzer IV veteran put it simply, "We had better tanks when they worked. They always had tanks that worked." Stabilizer exemplified this reliability. It wasn't a perfect system. American crews sometimes turned it off when it malfunctioned or when they didn't trust it. Training on its proper use was inconsistent, especially early in the war. But even imperfectly implemented, Even when crews didn't fully utilize its capabilities, it provided an edge, and American production methods meant that every Sherman, from the first to the last, carried the same equipment, allowing lessons learned with one tank to transfer seamlessly to the next. Thank you for watching. For more detailed historical breakdowns, check out the other videos on your screen now, and don't forget to subscribe. Germany never developed a comparable system during the war. After the conflict ended, German engineers who'd studied captured Allied tanks carried their knowledge into the post-war world. Some went to America, joining research programs that would inform the next generation of tank design. Others stayed in what would become West Germany, contributing to vehicles like the Leopard, which wouldn't receive gun stabilization until it was retrofitted in 1972, nearly 3 decades after Shermans first carried the technology. The Soviet Union, which received over 4,000 diesel-engined Shermans through Lend-Lease, studied the stabilizer carefully. Soviet tankers praised the feature, and by the 1950s, Soviet designers had implemented their own stabilization systems that would become standard in their Cold War tank designs. The British, who received thousands of Shermans and designated them with their own naming system, oddly enough, often disabled the stabilizers. British doctrine and training didn't emphasize firing on the move, and crews found the system finicky if not properly maintained. This represented perhaps the ultimate irony, a sophisticated feature that required institutional commitment to fully exploit. The Americans, who designed it, built the training programs and doctrine to use it. Others, receiving the same hardware, couldn't automatically achieve the same benefits. War Daddy 2's journey from the Tunisian desert to Kummersdorf represented something larger than one captured tank. It represented the moment when German engineering excellence confronted American industrial might and realized the contest was already over. Not because American tanks were better on a one-to-one basis, but because the American system for producing, deploying, and sustaining tanks was operating at a level Germany couldn't match. The gyro stabilizer was the detail that made this visible. A feature so routine in American tanks that it appeared in training manuals as standard equipment, yet so sophisticated that Germany couldn't implement it even in their most advanced designs. Not because German engineers lacked skill, but because American industry operated according to different rules. Rules that said, design for mass production, standardize ruthlessly, improve continuously, and build in overwhelming numbers. These weren't rules about making better tanks, they were rules about winning industrial wars. In the decades since, military historians have debated endlessly about tank versus tank comparisons. Was the Sherman inferior to the Panther? Yes, in direct combat. Could a Sherman kill a Tiger? Only with difficulty and usually multiple vehicles. Did German tanks represent superior engineering? In many individual measures? Absolutely. But wars aren't won by superior individual weapons. They're won by nations that can field capable weapons in sufficient numbers, keep them supplied and maintained, replace losses faster than they accumulate, and sustain operations until the enemy can no longer continue. On those measures, the Sherman's gyro stabilizer told the real story, not because it was a war-winning superweapon, but because it was a thoughtful improvement, implemented universally, that gave American crews a small but consistent advantage. Multiplied across thousands of tanks and thousands of engagements, small advantages became decisive. German test crews at Kummersdorf had understood this by mid-1943. They'd fired War Daddy 2 on their ranges, felt how quickly they could engage targets from halt, examined the manufacturing quality that spoke to industrial capacity beyond anything Germany could mobilize. They'd written their reports honestly, documenting both the strengths and limitations of what they'd found. Those reports couldn't change the outcome. By the time War Daddy 2 reached Kummersdorf, the decisions that would determine the war's end had already been made, not on battlefields, but in factories, not by generals, but by industrial planners who understood that modern warfare consumed equipment faster than pre-war armies could imagine, and victory would go to whichever side could sustain that consumption. The United States could, Germany could not. The gyro stabilizer was simply one more proof of a truth that became clearer with each passing month. Germany was fighting a kind of war it had no hope of winning. When Soviet troops finally overran Kummersdorf in April 1945, they found a testing ground in ruins. Some equipment had been evacuated, some destroyed, much simply abandoned. The captured Allied vehicles that had been studied so carefully were gone, their ultimate fates lost to history. War Daddy 2, if it survived until then, likely ended its days as scrap metal, indistinguishable from the thousands of other destroyed vehicles littering Germany. But the lesson it had taught lived on. In post-war tank design, in military doctrine, in how nations thought about industrial mobilization for conflict. The gyro stabilizer, a device most people have never heard of, became a footnote in history, a technical detail in a larger story. Yet, that detail mattered, because it represented the moment when German engineers, studying a captured American tank in the spring of 1943, realized their nation was facing an opponent whose strength lay not in individual brilliance, but in systematic excellence. An opponent who could afford to give every tank crew a small technological advantage because their factories could produce the technology 50,000 times over. In the end, War Daddy 2's greatest impact wasn't on any battlefield. It was in a workshop at Kummersdorf, where German engineers examined an American gyro stabilizer and confronted an uncomfortable truth. They were fighting a war where superior individual weapons couldn't overcome inferior logistics, where tactical brilliance couldn't compensate for strategic exhaustion, and where engineering excellence, however genuine, couldn't match industrial capacity. The Americans didn't need perfect tanks. They needed tanks that worked, that could be produced in vast numbers, and that gave their crews every small advantage that mass production could provide. The gyro stabilizer was one such advantage. There were hundreds of others. Added together, they represented an approach to warfare that Germany, for all its military tradition and technological sophistication, had failed to understand until it was far too late. That was the real lesson of the captured Sherman. Not that American tanks were better, but that American thinking about how to fight industrial wars was fundamentally different, and in the crucible of World War II, that difference decided everything. Preparing and narrating this type of story took us long efforts and hard work, so if you are enjoying the story, please consider subscribing to our channel.